In our last experiment, we successfully connected the DHT22 sensor to the ESP32 and used it to monitor temperature and humidity. We displayed the results in the serial monitor and even added an LED and buzzer to act as alerts when the values exceeded certain thresholds. That gave us a great start, but looking at numbers on the serial monitor is not always practical. Imagine setting this up in a real environment, like a greenhouse, classroom, or even a small indoor farm. You wouldn't want to keep your laptop connected all the time just to check the values. That's why, in this continuation experiment, we're taking things a step further. We'll connect an LCD screen directly to our ESP32 so we can see the temperature and humidity in real time without relying on a computer. This makes the project more practical, portable, and closer to a real-world IoT application. The LCD will show both the temperature and humidity values clearly, while the LED and buzzer will still provide instant alerts when thresholds are crossed. This way, our setup now feels more like a real monitoring system that you could actually use in a smart home or agriculture scenario. Let's start by adding the LCD to our circuit. In Wokwi, drag the I²C LCD onto the breadboard and connect its pins. The SDA pin of the LCD goes to GPIO 21 on the ESP32, while the SCL pin goes to GPIO 22. These two pins are special on the ESP32 because they are the default hardware I²C pins. GPIO 21 is SDA, which carries the data, and GPIO 22 is SCL, which carries the clock signal. By using these pins, we don't need to reconfigure the I²C bus in the code. The libraries automatically know where to send and receive information. This makes the connection more reliable and ensures the LCD can communicate directly with the ESP32. So to recap, SDA to GPIO 21, SCL to GPIO 22, VCC to 5 volts, and GND to ground. With this setup, the LCD is now ready to display our sensor readings. Now that our wiring is complete, it's time to upload the code to the ESP32. In the Wokwi simulator, copy and paste the full code into the editor window. These libraries allow the ESP32 to work with the DHT22 sensor, DHT-ESP.H, communicate with I²C devices like the LCD, Wire.H, and Liquid Crystal I²C.H, and use Arduino functions, Arduino.H. Here we assign which pins the LED, buzzer, and DHT22 are connected to. We also define the thresholds for triggering alerts, temperature more than 30 degrees Celsius or humidity more than 70%. The DHT object manages sensor readings, while the LCD object represents a 16x2 LCD connected via I²C at address 0x27. This setup block runs once when the ESP32 starts. It initializes serial communication for debugging, sets up the LED and buzzer as outputs, and prepares the DHT22 sensor for use. The LCD is also initialized and briefly displays DHT22 monitor before clearing. Note: on the ESP32, the default I²C pins are GPIO 21, SDA, and GPIO 22, SCL. These are used to connect the LCD, since they are the hardware I²C pins expected by the wire library. Using them ensures the LCD communicates reliably without extra configuration. Inside the loop, the ESP32 continuously reads temperature, T, and humidity, H values, from the DHT22 sensor. This happens every cycle. If the sensor reading fails and returns NaN, not a number, the program shows sensor error on the LCD and waits 2 seconds before retrying. This prevents incorrect values from being used. The temperature and humidity values are displayed in 2 places: the serial monitor for debugging and on the LCD for live monitoring. The LCD prints temperature on the first line and humidity on the second. If either temperature more than 30 degrees Celsius or humidity is more than 70%, both the LED and buzzer are activated. Otherwise, they remain off. This ensures the system gives an alert for either high temperature or high humidity. Finally, the program waits 2 seconds before taking the next reading. This matches the DHT22's recommended update speed and makes the LCD output readable. And that brings us to the end of our LCD and DHT22 experiment with the ESP32. In this lesson, we took our previous project a step further by adding an LCD display, making our setup more practical and closer to a real-world IoT system. We successfully read temperature and humidity data from the DHT22 sensor, displayed it on the LCD, and activated an LED and buzzer whenever the readings went beyond safe limits. This experiment shows how powerful the ESP32 can be when combined with sensors and displays, allowing us to create systems that are interactive, responsive, and useful in everyday situations like home monitoring, classrooms, or even agriculture. Thank you so much for watching and following along with this tutorial. I hope you found it helpful and inspiring for your own projects. Don't forget to like, share, and subscribe so you won't miss the next experiment, where we'll push this project even further. See you in the next video.